Hello and welcome to the Introduction to Unity workshop. My name is Jonathan Tigner, but everybody calls me Gene, so you can just do that and call me Gene. It is my middle name. So, a little bit about me. I'm 29 years old. I graduated from UTSA in May of 2020 with a bachelor's degree in Science for Computer Science. I interned at Booz Allen Hamilton, later interned at MedCognition, and I now work for MedCognition as a full-time position with software engineer. For Booz Allen Hamilton, I helped them to create serious games for the military, anywhere from AR, VR systems to standalone desktop applications. These could be training manuals or training simulations. Working with MedCognition, I mainly focus on AR medical training simulations using Microsoft HoloLens with Unity, Electron apps as web development with Angular, and also some Android development with Unity as well. Most of my time is spent actually between Unity and Angular a lot. I'm point man on their Angular project. But anyway, this is a Introduction to Unity workshop, not Angular. So moving on. What is Unity? Unity is a game engine. It's as simple as that. It's basically just the tool, all the tools you need to be able to make amazing experiences kind of rolled into one spot. It has a bunch of different subsets of tools within it that honestly we might not even get to in this video. Why use it? It's free. And it's moderately easy to use. Anybody that has used Unity for a substantial period of time will tell you that it is very frustrating to use sometimes. It definitely needs a lot of work in a lot of areas, but it is what it is and you get what you pay for. So, and the programming language that it supports is C#. I know in the past, it used to support JavaScript. I do not believe that you can code in JavaScript anymore in Unity. I might be wrong on that. Y'all can double check me on it. I'm not going to look at it. I don't code in JavaScript in Unity. Never have. Probably never will. C# all the way for this. So, what do people make with Unity? You guys have probably played at least one of these games. And if you haven't, I don't know why you're here. I'm just kidding. So, Unity development has become very, very, very popular in the last couple of years. The biggest name on this list is more than likely Pokemon Go. But if you haven't played any of these games that are on this list, I recommend at least one of them. Like any of these. I've played, except for Ori and the Will of the Wisps and Fall Guys, I haven't played those two. But every other game I've at least touched or played. And Cuphead, I haven't played Cuphead either. But regardless, aside from just video games, people also make amazing educational experiences or standalone applications that they need Unity for some particular rendering aspect for it. Let's see, VR applications, anything that I talked about earlier that I worked on in the past is usually made, it can be made with Unity. Unity has a bunch of different platforms that it supports, which we will get into momentarily. And with that being said, I'm now going to transition to actually showing you guys Unity for the first time. Something to keep in mind that this is an introductory level workshop. I am starting from, I'm assuming y'all have no idea, have never even opened Unity before. So that's where I'm going. So one of the first things I would like to talk about is the Unity Hub. It is a hub that allows you to manage and maintain your versions of Unity that you have installed. You would want to have multiple versions of Unity installed in the off chance that for some reason an older project that you made with a later version of Unity doesn't support the newer versions of Unity. That could be anywhere from deprecated content that Unity no longer supports to other things that may be missing out of newer Unity versions. So they also have this community section that allows you access to Unity's forums, easy place to get answers that you need. Also, the Learn section is a great resource for learning new things within Unity that you may not have known before. Additionally, this is where you would also start a new project here, and a pop-up window will come up and it'll ask you what type of project you want to start. Or you could install Unity as well through this installs section. You'd click on the official release, and then it would ask you what you would want to have, like Android build support, Universal Windows platform build support, any of this stuff, depending on what platform you're building out to. And it'll install all of those dependencies. So, whenever you first open up Unity, you'll probably see something like this. And I would like to spend a little bit of time here to talk about the user interface, because it can be pretty daunting for people who have never seen this interface before. I know it was for me whenever I first started out. So I am just going to go over some areas here, and we'll start getting into the more particular tools momentarily. So first of all, you have the hierarchy to the left, the scene view in the middle, along with the game view and the asset store. But we're not going to get into the asset store, so I'm just going to go ahead and close this tab. We also have the inspector to the right, the project view on the bottom, and the console. So first, I'm going to go ahead and talk about the project view, because this is where all of your files are going to exist just starting out. So right now, all we have is a scene folder and then a sample scene. And a scene is basically just the place where all of the game objects live inside of your current view. So this is the scene view here. I can move around by pressing the right mouse button. It gives me like a swivel kind of motion. I can move around with holding the right mouse button, and you can see that a WASD kind of movement comes up. So you can do that to move around, kind of floaty. You can also move around by pressing the middle mouse button. And as you can see that as I am pressing my mouse buttons, the context is changing up in the left-hand corner here. It's kind of showing you what tool is necessary to get that job done. But it's much easier, rather than clicking this and moving this around, to just click the middle mouse button or click the right mouse button. So that's how you move around in the scene. So there is a direct relation between this particular scene file and what you see here. There's also a direct relation between this scene file and this hierarchy. So I'm going to go ahead and open up the sample scene. You can see that changed from untitled to sample scene. And in this sample scene, we have a main camera game object and a directional light. And as soon as I click on these items, these game objects that exist within my scene, you can see that context changes not only in the scene view by showing you what is actually being clicked on, but also in the inspector. The inspector is your view for everything that exists on the game object. So on your game object, you have different components. Components together make up a game object, and game objects will always have a transform component. This is a non-removable component. It has to have a transform, and the reason it has to have a transform is because game objects are aware of their space in Unity through the transform, not only their physical space, but also their relation to other items. So if I was to make another game object, it would know its relation to other game objects. So if I made this empty game object, it knows that this is its parent game object through the transform. It comes in very handy programmatically later, which I will show. But I don't want to spend too much time talking about the nitty-gritties of Unity's user interface. For now, it's just important to understand that game objects exist in a scene. Game objects have components. All of your assets files live underneath the project view, and the console view here, nothing really is happening right now, but the console view will come in handy later whenever we hit this play button up here and we start seeing some console logs that we've coded out. You'll also notice that when I added a game object to the scene, this little asterisk came up. So what that means is that the scene is not yet saved. So you can save that by hitting Control S, but also you can just save the project as well. But you should probably take note that saving here with Control S and saving the project might not always save your scene. So save with Control S always, and then save your project if you feel the need to. So I also want to mention that every scene must have a camera. And every scene must also have an audio listener. Well, I guess technically, no. You can only have at most one audio listener, but you don't technically have to have an audio listener, especially if your app doesn't produce any audio. However, if we delete the directional light, first of all, you get this gross color because now there's technically no sun. And on top of that, if you delete the camera, you get this message in your game scene that there is no camera running. So there needs to be a camera in order for your game scene to have any renderable items. So I actually want to talk about what makes up a scene file real quick, because one of the bigger problems when you're working on a team in Unity is merge conflicts with your Unity scene file. And I just want to show you guys, if you show an Explorer the particular directory that has your scenes in it, and you can see that you have this Unity icon and it has a sample scene and it is of type Unity scene file. If you right click on it and you hit open with code, or if you have Visual Studio Code you can open it with code, you will see that this is a .unity file and it is a YAML 1.1 file. If you're not familiar with YAML, don't worry about it. Basically, it's like JSON, but you can put comments in it. But anyway, this is what a Unity scene looks like to Unity. It is just a bunch of data. And you can see that here's one game object in our scene. And here, let's see, it's a light map setting. Here's a nav mesh setting. Here's a game object. And there should be another game object. Here's another game object, and here's a transform. I believe this transform is for this game object up here. It has its world positions for its rotation, its position. Let's see, its file ID for the game object. But basically, this is slightly not human readable because right off the bat, you don't really know what game object this is. Let's see. Here we go. Directional light. Had to kind of look down here, but there is a name here for directional light. But regardless, say you have hundreds of thousands of game objects in your scene, and all of a sudden your scene starts to get really, like right off the bat, this is already 298 lines long. And if you have a merge conflict in here, it's not always easy to know, which way to go with the merge conflict. Do you keep the old? Do you keep the new? And it's just kind of a mess. So I highly recommend trying everything you can do to avoid merge conflicts. I know they're pretty inevitable, especially at hackathons when you're working very vigilantly and trying to get things done. But honestly, having a merge conflict with a scene file and a corrupted scene file is not something you want during your project. It can eat up a lot of your time trying to figure that out. Ways to circumvent merge conflicts. So let's talk about that because that's important for hackathon projects. What you can do, say you have made a scene and say you have a cube in here or something and it has a custom component on it that you just absolutely have to have for the rest of your project, but you don't want to cause a merge conflict, and you know that if you save this scene as the way it is and you try to push it to your repository, it's going to cause a merge conflict. What you can do is you can right click and go to, actually it's not in here, one moment, you can prefab out the object that you made. So what this will do, it'll save this game object in your assets folder. It'll save every state. It'll save all the components on that game object will also be saved with it. And you can right click on it, or if you feel the need to do so, so you have a lot more files, you can also right click on the file structure, but you can right click on this and you can go to export package. And what this will do is it'll go here and it'll include, you can either have it include all the dependencies or not if you don't want to, but for now there's just one item, and that's this prefab. And you can export this as a Unity package. What this allows you to do is you can then give this to your teammates and they can import it into their project, and you can show them how to connect everything together, and you've just avoided a merge conflict. And you can just, after they implement it on their scene and everything's pushed up the branch with that avoided merge conflict, you can then pull that back into your project and have those files readily available. So just a small tip there. Right click on the asset that you've created, export the package, export, save it as something, and then you have that package here. And whenever you go to import it, so you import this into your project, you'll get a import window. Right now it tells me that nothing is to be imported because I have everything that I need, but for the sake of you guys understanding, if I delete this prefab, as you can also see that this is now red because its prefab is lost. I'm going to delete that, and I'm going to come here and pull this back into my project. And you can see that now this is wanting to bring this new prefab into my project, and I can hit import, and I can put this back in my scene, and there's the cube again, the one that I had saved. So now we're going to transition into a project that I have already built in Unity. It is a tic-tac-toe game. And the first thing you're probably wondering is why my screen looks different. And it's really not that much different. I just moved some of the windows around. You can click and drag these wherever you want, and they'll snap to different corners of the screen. I just really like the way that this is set up, where the project and the hierarchy are sitting really close to each other, because I would like it to be actually the hierarchy on top and the project view on bottom. Makes more sense because the inspector is right here, you know, it's right next to each other. So that's just one of the settings that I like to have things close to where their like kinds are at. Anyway, so I built this project out as kind of a way to show you a fun little project, or it's already working in Unity, that you guys can like dig your teeth into if you felt the need to download this. It is there is a repository that you can go to and download. Should have been provided in the resources for this course or for this talk. But anyway, I'm going to go ahead and play this game. I'm just going to mute the audio here. There is an audio soundtrack that plays whenever you play, but it's basically just a simple little tic-tac-toe game. So you fight the computer, and if you're lucky, you'll win. And if you're not lucky, you'll lose, and it just counts over here. And let's see, this console, you should be able to see some logs here. So it is coming to conclusions and making decisions as you play the game. Anyway, so let's talk about, now I'm going to spend the rest of this talk kind of not really getting into the nitty-gritty of the code on how I made this, but I'm more going to be talking about how Unity handles certain variables in certain ways that makes your job a lot easier as a developer, especially when you're working hand in hand with the designer. Because a game designer is someone who's kind of a different skill set than a game developer. You know, they're two different jobs. So someone codes and someone designs. Unfortunately, I had to play both roles. And most of the time, especially if you're a video game developer hobbyist, you're going to be playing both roles. It is a very unforgiving field. So let's go ahead and start off by looking at the scene view here. So I switched over from the game view to the scene view, and you can see right off the bat that some things are kind of weird. First of all, the main camera is sitting at a very wide area. I'm in 2D mode right now instead of 3D mode. So this is what it looks like 3D. This is what it looks like 2D. And my camera doesn't exactly point to where my user interface is sitting. And that's because of the way that Unity handles user interface. It sits on its own plane and it maps to the outline of the camera or the edges of the camera. And that is so that way you can control the aspect ratios. And I did not set this up in an intuitive way, so it's kind of gross with the aspect ratio. So I recommend playing this game in the 16:9 aspect ratio. So my hierarchy consists of the main camera, which is a must-have, because if we didn't have the main camera, it would say display 1, no cameras rendering, and it would not render properly. It has a directional light, which I'm technically not using, so I could turn it off if I wanted to. Doesn't change the game view. It has a canvas, which a canvas is where all of the user interface lives. The 2D UI is on the canvas, and that's where the bulk of this project exists. This event system is for our button clicks. Unity has to have this event system or else it won't register button clicks with your mouse. It has a game manager, which is a game object that I created that controls the state of the game as it goes through. And it has this particle system that I'm not using. I don't know why it's here. So let's start by talking about the game manager and what these fields represent. All right, so the game manager. As you can see, if you click on the script icon here, it'll open Visual Studio, and you can see, as soon as it's done loading, this game manager script that I've made. Go away. I went ahead and made this a bit easier to digest by putting things where they need to go. So I seem to have lost there it goes. So sometimes Visual Studio will lose reference to certain hooks that Unity likes to give. Anyway, so this is just a standard game manager that is using a singleton design pattern. Right here I have some variable declaration going on. You'll see that these tooltips here are some interesting things. So when you have a public field or a serialized field on a private variable within your script, Unity will do this very unique thing where it maps them out on the actual object. So if I wanted to come in here and create a public variable and it's of type int, and say it represents some sort of I don't know, count of some sort, I can save this, and then Unity will recompile, and sometimes it takes a little bit, but then you'll see that it actually pops up here in the component that you've made for the game object. Now this game object, if I press F while I have it selected in my hierarchy, it'll take me to where it exists in the scene, but you know, it's so tiny it doesn't really matter. But this tiny little guy is actually doing a lot. He has references to the game board, which is right here. He also has a reference, let me go ahead and lock this in place so I can show you stuff. Board squares, which is a prefab that exists in my assets folder. And this prefab doesn't yet exist in the scene. It's because I'm quote unquote instantiating the game object at runtime, where I'm generating them at runtime. I've defined how many moves a player can make, or the maximum number of moves a player can make. Technically, the maximum number of moves a player can make is, I believe, 9 divided by 2 4.5, so 5 is the max number. So I just went ahead and did 9. I'm doing this specifically to keep track of moves that a computer cannot make. And so it has reference to board squares. It has reference to the buttons on the board. Has reference to players' moves, and it keeps count of how many moves have happened. Additionally, there is this favored square button, which I don't think I'm using anymore. Let me see something real quick. Yeah, I think I'm doing that programmatically. As you can see, it filled it in at runtime. So I also have an audio source for the beeps and boops. I think this audio source actually is just taking care of the soundtrack that's playing. But anyway, so if you're building a game, do you want a game manager? Basically, you should build your game in a way that has states that are controllable by the manager. Usually your game has some sort of points. Maybe you have a currency system in place. Your game manager should be the one that takes care of all of those overarching items. You may want individual managers elsewhere, but the game manager should be aware of those managers in some degree. At least, in my opinion, it should. So let's go back to the game manager script. You can also see these tooltips here. This is a decorator for this variable. So I'm going to go ahead and get rid of this count variable here because I'm not using it for anything. And you can see this game board here is represented here. And if I hover over it, it pops up that tooltip. So this is a great way to have a game designer understand what these fields are for in Unity. So now that we've talked about how Unity will represent variables in here, sometimes you don't want variables to show up, so you can just have them set as private and not serialized. I believe I'm doing that here. No, correction, this is public. Right here. So where I'm keeping track of point count for player X and player O. These are private and not exposed to Unity, so you will not see them on the game manager in Unity. There's no reason for these to be exposed. All right, moving on. So I'd like to talk about another reason why it is nice to have variables like this exposed. So if I'm running this game and I'm trying to debug something and I want to see the data and how it's structured, I can come in here and just look at what the program is doing as I'm making decisions. So say, I believe these indexes, a 0 represents a free move, a 1 represents a move that I have taken, and a 2 represents a move that my opponent has taken. So if I hit an X here, okay, so I have taken element 0, and my opponent has taken element 2, or element 4, which would be the 4th button, I believe. Yep. So it should be this one, which is also this favored button. So if I keep playing this game, you will see that I am creating a sort of matrix of information. And we filled out all the available moves available. I've gotten to the max moves available from all players, and it comes across with this really nice, beautiful data set that I can see. I can see all the buttons that are on the board, and I can see that there are no board squares left as valid moves. So restart this, and you can see that I also have a way to identify a winning move by just extrapolating this data. So being able to visually see the data as you are playing, and also being able to output debug log messages is a great way to help you understand what your program is trying to do and helps you debug a little bit easier. So now let's talk about something that I think is really important to understand, and that is how the relationship between a game object and its children's game object in Unity is not straightforward. You would think that a game object would be aware of its children, and it kind of is, but also kind of isn't. A game object's transform is aware of a game object's children, but not a game object itself. If I tried to do a for each loop on a game object, it would not know what I'm talking about by trying to find the other game objects. I have to, if I want to get, if I have a static list that exists of items like this, like I have here where it has the game board and the board squares underneath them, I would either have to have some predefined list, like I'm doing here on the side with this, or I would have to have some way to get to those items just by using the predefined hierarchy, which I will show you in a minute. So I went ahead and looked through the code, and I'm actually not doing this anywhere in the code because I took a different route. But I am going to go ahead and show you guys how you would reference, say, a game object and its children. So say that this game object that this code is on, game object that this code is on, has children game objects, and I want to get to them. Well, how would I do that? I could say for each, and then I could say transform child in this.gameObject.transform, because the transform is aware of other transforms underneath it. And I could then say that, say I want to either log it or something, I'm not sure, but you can get to those children and since this child is a transform, you can reference back up the chain to its associated game object. It is kind of wonky. It's not. It's weird, in doing it this way, because here I'm referencing the transform through the game object, but now I'm referencing the game object through the transform. It's circular, and Unity is so weird with that circular logic, to the point that if you wanted to, you could say this.gameObject.transform.gameObject.transform. That's valid, and like I promise you that's valid, because I can say transform this, or not this. This is protected. Example, and I can set that, and it's super stupid and circular. Like, I'm telling you to go from the game object to the transform, back to the game object, back to the transform. It's self-referential. But the upside to that is you can make that weird for each loop to get to the children game object, or to the child game objects within your hierarchy. Don't do this, by the way. Please don't do this. If I ever see a repository that has this in it, I will just die. So let's go ahead and talk about a few other things. So you'll see that I have these scripts here. And one is the game manager. This is a custom script that I made. Unity recognizes the keyword game manager, so it gives it importance by putting this little cog next to it. These are some other scripts that just kind of give flair. So this mover script, all it's doing is rotating this back image. Whenever you hit play, this giant circle just rotates. This scoreboard content controller controls the scores as you play the game and update the scoreboard whenever you win or lose. And then this Tic-Tac-Toe button controller is where the bulk of my decision making for the computer comes in, and the artificial intelligence. If you want, you can go through these scripts, kind of learn what I'm doing. I'm going to go over just a couple things in this Tic-Tac-Toe button controller. You'll see that I am using this button class in one of the lists. List button. Am I not using it here? Thought I was. Well, regardless, there are certain times you'll need to use the unity.ui library whenever you have like a list of buttons or something like that. This is a library class for that Unity UI library. So just kind of keep that in mind. Sometimes you'll need to have a knowledge of what library to be using. Here I'm using system collections to link library. So these are just regular C# libraries, where these are Unity specific libraries. You'll also notice that I'm using these, that this is a mono behavior. This isn't just a normal class. It's a mono behavior. And basically what that means is it kind of tells Unity, hey, this thing has something to do with my lifecycle hooks. And Unity lifecycle hooks are very important to understand. There are a bunch of key different ones. Here I'm using start and update. And basically the only thing I'm using the start for is setting up the game. And the only thing I'm using the update for is checking to see if the user presses the escape button on their keyboard, so that way it closes the application after the application has been built to a standalone app. This won't do anything in the editor. It'll only do this at actual, it'll only do this at actual runtime. Why did I do that? Don't save. Okay. So, why use Unity lifecycle hooks? The reason you would want to use Unity lifecycle hooks, like here I'm using the awake function, is so that Unity can control the flow of the game. So this particular documentation talks about the order of execution for event functions, and it is one of the most important pieces of documentation that'll get you to start understanding Unity's lifecycle hooks and where things actually start to come into play. You have the awake lifecycle hook, which is the very first thing that happens. All of these lifecycle hooks exist per game object, as long as you have a script connected to that game object that is a mono behavior. So this awake function, and I believe they kind of have some level of synchronous behavior. So awake will always happen before on enable. And okay, I actually can't remember this. I don't know if all the awake functions start at the exact same time or if there is a delay. There may be a delay. Don't quote me on that. Anyway, I know at least for script on one game object, awake will happen before on enable will happen before reset will happen before start. And then it gives, this is very informational, like physics. Fixed update is for physics. Game logic, you have the update function, which is for game object, and then you have late update, which is the exact same as update, except it happens last. I have not really used most of these. I use awake a lot, I use start a lot, I use on enable occasionally. On enable is whenever you enable a game object. So say you have this canvas or this scoreboard and you turn it on and off, that's enabling and disabling the game object. So what happens programmatically when you enable or disable, you can be that specific with it. Fixed update is for physics, like I said earlier. If you're doing something that requires physics, please put your physics calculation into fixed update. If you put your physics calculation into update, you're going to have slow and kind of weird physics. For normal game logic, you have the standard update function, which happens every single frame render. So don't put an infinite while loop in your update loop. That doesn't make any sense. You will crash your system. You cannot finish your computation of an infinite while loop inside of an update loop, especially if you run the update loop again. Now you have two infinite while loops. Scene rendering, I've never used any of these. On disable, I've used. On application quit, I believe I've used it. On destroy, I've used. So on destroy will happen, whenever you delete a game object programmatically, it'll run the code that's in there before it finally deletes the game object. And then after that one, it comes all the way back up here and back to awake and just continues this loop. So understanding where to put your code on this lifecycle hook is really important. Okay, so I made this Tic-Tac-Toe broken scene. If you go to the assets and then the scenes, you'll see that there is this Tic-Tac-Toe broken scene. It has a red background. And basically, what I've done is I've just gone through and I've removed some essential items from the game manager. So whenever you go to run this, it shouldn't run. Or rather, it'll run, but it'll have this error here saying that I have an unassigned reference exception. And what I'm doing here is I'm just trying to show you how Unity is really informative when it comes to this type of thing. So say I'm clicked on the canvas and I have this error and it's telling me that the variable board square of game manager has not been assigned. If I click on this, it'll take me right to the game object that's having a problem. So as you can see here, it's talking about the board square variable. So this particular variable needs a board square. And I can go to my assets and I can click on this board square. And I did that during runtime. If you do stuff during runtime, it won't save. So went ahead, add this here, hit play again, and let's see, clear on play. Let's try this again. All right, now this should work, but now I have another problem. Now I have an index out of range exception. So what could be causing, this index out of range exception? If I click on this, double click on it, it'll bring up Visual Studio, and it's saying that this particular integer array for the opposing player is having a problem accessing this particular index. Well, if we go and look at this opposing player, it has only 2 indexes instead of 9, so we can fix that. And if we go ahead and restart this, let me put that back to 9, hit play here. Now I should be able to make moves, but I believe there is one more bug. Yep, here's one last bug that I have injected into here. It's a null reference exception. It says object reference is not set to an instance of an object. These ones can be a little nefarious because they're kind of not explicit. But it is telling us that this is coming from check manager check for winning state. So if I click on this, it'll open this and it'll take us to line 203, and it'll say that this function, is that something here is a null reference exception. So I'm going to go ahead and assume that my scoreboard controller is not being defined. So if I come over here and I look for the scoreboard controller, and look at that, none. So if I click on here and I go to my assets or my scene, there is no scoreboard here. So how can we fix this? Well, we go over to the canvas and we come over to the scoreboard. I believe the scoreboard has a scoreboard controller on it, which it does. Additionally, if you are having a hard time finding this, you can just type scoreboard, or you can type the name of the component, scoreboard controller, and then it'll reference that exact item. Additionally, let's see. So let's go ahead and if you hit this X button, it'll still maintain focus on that scoreboard. But we need to update the game manager. So we have to click back on the game manager, lock the game manager in place so it doesn't reference the other item. Click on this scoreboard game object and drag it into here. Because it has the appropriate component on it, it'll let us drop it into this little zone here. So now all of the error messages should now be gone. So I can play the game as normal. But there is one more problem on here, and I'm wondering if y'all can find it. I'll give y'all a second. But this is a recorded video, so I can't exactly give you a second. The background isn't moving like it should. So how can we fix that? Well, let's click on this. Polka dots here. Let's unlock the game manager so we can have some polka dots. And we can see that the speed slider that I've set up for this particular class is set all the way down to 0. So this actually brings up a nice thing. How I'm putting the slider in here is by using the range decorator on the float. And I believe it has to be a float in order to be able to get this slider. So let's go ahead and go to this mover script. And I can show you guys that I'm using this range decorator from 0 to 10 on this float. Highly do not recommend setting a number with also having a range. Not a good idea. If you're going to do it this way, either set the number here in Unity or not at all. I've had issues where Unity has kind of crapped out on me before because of out of bounds float settings with the slider. And one of the last things I'd like to talk about is more GitHub stuff. So a couple things. First of all, especially if you're going to be using like a really big Unity project, asset files can get really big. So you probably want to make sure that you're using Git LFS. And if you don't know what that means, it stands for Git Large File Store. And it's specifically for projects that have meaty, beefy assets. Secondly, I highly recommend using this particular git ignore, because you definitely don't want to put a bunch of nonsense that's going to get recompiled anyway on somebody else's computer on your GitHub repository. There's just no reason to push all that stuff up. So I highly recommend using this git ignore when you start out your project. And that's pretty much it. So now I'm just going to open the floor for questions.